Hi, my name is Jesse Tasman. I'm a senior technical product manager here at bloXroute. And today we're going to talk about the MEV pipeline that exists on Solana and the different elements of that pipeline and the problems or friction points that exist for users, as well as how bloXroute comes in with certain solutions to help smooth that process out. So, starting off at a very high level, basically just to understand what this MEV pipeline looks like on Solana, I've broken it up into three distinct sections. The first one being data discovery. So, in order to operate, if you're a searcher, a trader, whatever it may be, you're running some type of trading strategy, whether it's arbitrage, copy trading, liquidations, whatever it may be. The first element that is extremely critical is being able to receive on-chain data very, very quickly. And then we move on to the second phase, which is the actual local operations. So what do you do with that on-chain data that you've discovered very quickly? So you then, need to process it in a way that goes with whatever strategy you're running. So understand what these, state changes or whatever it is, what's happening there, how are you reacting to it, and then you react in a way that results in you compiling certain transactions of your own, and then getting those transactions landed on chain, which is the third stage. The transactions you create, you obviously want landed on chain very quickly and very reliably, so that even in very congested network periods, you are still able to get very reliable execution of the transaction that you're putting together. And we know that on Solana specifically, with a very short block time, speed is incredibly important, and reliability, as I mentioned, because the network does tend to get congested during very high volume times. So these are two elements that will give you an edge over competitors in the space. Now, if we double click into this first stage of data discovery, so really what that means is you're looking to receive threads or transactions as quickly as possible. And we'll double click into what exactly that means in a second. But just starting at a high level to understand how Solana operates. So essentially, Solana operates in the form of there being a leader for every slot. So, every epoch, which is approximately 432,000 blocks, 2 days, there is a deterministic schedule that's put into place, and leaders are chosen for every slot in that epoch. And the way a leader is chosen is probabilistic, weighted by how much stake they have on their validator. And then this rotates through. They get 4 blocks to be the leader for every slot. And really, when they're the leader, they're in charge of creating the block. So they get all transactions sent to them at that point in time. They compile the block, and they then propagate this block to the rest of the network in the form of shreds. Now, what shreds are at a very high level, you can think of a block being, grated up in a cheese grater or put through a paper shredder, and it's just different parts, smaller little components of the block that on them by themselves don't mean much. But once you have access or have received a certain number of these shreds, you're then able to reconstruct the original block that the leader put together, and then obviously get access to all that block's content, such as all the transactions that are included in that block. And this is done using a very smart mechanism where it ensures high reliability. So even if certain shreds get lost along the way, there are recovery shreds, and you're essentially able to reconstruct the block once you've received a certain amount of these. Now, let's get down to how these shreds are actually propagated through the network. So as I mentioned, the leader is a single validator that obviously has a very high amount of stake, since they were probabilistically chosen to be a leader in for certain slots in the epoch based on or that probabilistic determination was weighted by how much stake they have. So only really high stake validators get the chance to be leaders. And then the order of who receives the shreds that they propagate from the block they constructed is also, again, determined or rather weighted by how much stake each validator has. So the turbine protocol is the default mechanism for how shreds are propagated to the network. And essentially what happens is the leader sends the shreds of the block that they put together to a root node. That node then disperses or distributes those shreds to nodes that are on the next hop, and it goes down like a tree in that way. Now, the point to make here is that ultimately where you are in that turbine tree is determined ultimately by how much stake you hold. So although this changes, if you have more stake, you're going to be higher up in that turbine tree. And what this ultimately means is you're going to be receiving shreds faster than the nodes or validators with less stake in the network or no stake at all. So this really brings to light the core issue in that only a select few validators are going to be able to receive shreds extremely quickly and extremely reliably, whereas those with little to no stake are going to have to wait a lot of time, and they'll experience delays. They might not receive all the shreds. It gets messy, and it causes a huge discrepancy in data discovery, which is weighted based on how much stake exists. So you're at a disadvantage if you don't have if you're not one of the highest staked validators on the network. Now, to address this core challenge, bloXroute's has what's called their blockchain distribution network, or BDN, which is essentially a global relay of different clusters around the world in strategic locations. And this ultimately works in the way that data is distributed in a very optimized and low latency way. And then in order to access this, we have our optimized feed relays, or OFFER, where consumers are able to essentially plug into this network and receive those either raw shreds that are being distributed from the leader, or the decoded and parsed version of those shreds, which are ultimately just transactions. So that is how you're then able to plug in, and even if you don't have a huge amount of stake, you're able to receive shreds or transactions so fast it's as if you did have a huge amount of stake, or if you were the root node in that turbine tree, receiving shreds directly from the validator. That's obviously like the north star of this type of a product, is to give every single user the ability to discover data as quickly as those top validators in the network for whatever configuration they're in for each slot. So just to drill down a little bit more, when I speak about shreds versus transaction streaming, so as we looked at, shreds are essentially just those raw components that you need to collect in order to reconstruct that initial block. So depending on your use case, you are either happy receiving those raw shreds and processing them, like decoding them on your local side, and using them in whatever way you see fit. Let's say you're a validator and you want to improve your speed at which you get to vote on the canonical chain to kind of improve your your voting rewards, or you just have very custom ways of decoding shreds and parsing them on your side. For those kinds of use cases, you would like to receive raw shreds directly. However, if you are someone like a searcher or a trader performing different types of on-chain trading strategies, you may be more interested just in the transactions themselves. And there's a lot of technical overhead which comes with parsing and decoding shreds. So we also have the ability for you to stream the already processed shreds in the form of transactions, which may be a lot better for your use case. But either way, you're getting access to this data a lot quicker than you would through kind of default turbine propagation. And if we look at, what is the actual performance of this relative to that turbine propagation? So if we just look at shreds versus receiving shreds through off-air versus receiving shreds through turbine, we see that in virtually 99% of cases, you're going to see a shred first through off-air than you would through turbine, and often significantly quicker. So almost 30% of the time, not only will you see it first through off-air, but you're going to receive it more than 50 milliseconds faster than you would through default turbine propagation. Now, in the real world, I touched on some of these use cases, but basically discovering data quickly is important to a lot of different players in the ecosystem, whether it be validators looking to increase their voting rewards, whether it be traders looking to receive trading signals quicker and act quicker, get an edge on their competitors, analytics companies indexing blocks and transactions a lot quicker. There are a lot of different use cases that speeding up data discovery on Solana applies to. One of the use cases that I didn't mention earlier is snipers, for example. So obviously something there for this use case, you want to be able to react extremely quickly when you see a new like unbonding from a launch pad into a new liquidity pool. You want to be able to buy as quickly as possible. And the faster you receive that trading signal that this liquidity pool has been liquidity has been added to it, the faster you can then react and get preferable prices, buying prices, than if you were to receive data slower and act slower. That being said, there's also that second component in the pipeline, which is actually landing those transactions. So in the case of a sniper, for example, yes, you're going to receive the trading signal saying, let's say, liquidity has been added to a pool. You can receive that really quickly. But then if you're not able to get your buy transaction landed extremely quickly as well, it's kind of worthless. So you need that second component of landing transactions very quickly in a very reliable way in order to complete this pipeline end to end and really be operating in a very strong fashion. So just touching on how bloXroute comes into play with the part of landing transactions, we have what's called our trader API, which basically ensures that under whatever network conditions there may be, even if it's extremely high traffic and very congested, we have the mechanisms in place to ensure that you land your transaction very quickly, and again, very reliably, even in very high traffic network conditions. And then there are also different configurations that you can choose when sending your transactions based on the trade-off that you want to make against between front-running protection versus speed of landing. So we put in a lot of effort to kind of map out the validators that exist that act maliciously and tend to front-run transactions. So we do have really good mechanisms for being able to ensure that your transactions are not front-run. But if you're, depending on your strategy, kind of less interested in that and more interested in landing transactions extremely fast, we also have a very good, strong, trusted network of high-stake validators that we use to send our transactions through. And they're obviously able to send transactions to the leader using the different bandwidth component that the leader allocates to high stake validators. So there are a lot of different mechanisms in place to always ensure that your transactions land on chain as quickly and as reliably as possible, even customized to whatever your preferences are in terms of speed versus front running protection. Of course, we're always looking to improve and add new regions and be a lot quicker. But hopefully this presentation just helped give a little bit of context into the kinds of things that we're working on to ensure that everyone can operate on some type of a fair playing field and get that edge over people that are not partaking in what we have to offer.